In this short class we're going to look at the median and quartiles for a data set. The median is just the middle value, and the quartiles we'll see are the first quartile, the first quarter of the data set, and the last quarter of the data set. We'll see how it works in a moment. So let's take the median. Well, if a data set is arranged in ascending order of magnitude, then the median is the middle value of the data set. And we calculate that by simply saying it's the number of items in the data set. So let's say we've got 9 values in the data set. 9 plus 1 is 10. Half of 10 is 5. So the fifth element in the data set is the median. It's halfways. If you look at this data set here, I'll just put the cursor onto the screen. We got 18, 20, 23, 20. So it's going upwards and now down from 23 down to 20, up to 23, 27, down to 24, down to 23, up to 29. So we need to organize that in ascending order. So we start at 18, 20, 20, 23, 23, 23, 24, 27, 29. So it's in ascending order. And also we count. If we count these, we've got 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values across here. Now if we apply the formula here, our simple formula, we have the median is equal to n plus 1 over 2. We have 9 pieces of data here, 9 of them. Add 1, so the formula tells us to add 1, which is 10, divided by 2 is 5. So the fifth element is the median. And we count along 1, 2, 3, 4, 5. That is the fifth element, which is the median. And that's how we calculate a median. Now to look at quartiles, here we have a data set. If the data in the set is arranged in ascending order of magnitude, then the lower quartile is the median of the lower half of the set. So the lower quartile is the median of the lower half of the set. So we divide the set in 2 and find the middle value in the bottom half and the middle value in the top half. The lower quartile is called Q1. So Q1 is just a quarter of n plus 1 value, where n is the number of values in the data set. It's the same formula almost as the median, except now we're dividing by a quarter. We're dealing with quartiles. So quartiles, quarter, dealing with a quarter. Now, if we take our data set above, we have 9 observations. 9 plus 1 is 10. Divide 10 by 4. Here's our formula. Divided by 4, which gets the 2.5 value. We've written the 2.5 value. 2.5 would be somewhere in here. So what we do in that case is we take the one just below it and the one just above it. So we take the second and the third and take an average, which in this case is simple. It's 20 plus 20 divided by 2, which is 20. So we're taking an average of the second and the third, because it's 2.5. The upper quartile, well, the upper quartile is 3/4 away along the line. So we'd take our formula here, and it's 3/4 way along. So it's Q3, 3/4 way along. And again, we have 9 plus 1, which is 10. 3 times 10 is 30. 30 divided by 4 is 7.5. Count along. 1, 2, 3, 4, 5, 6, 7. 7.5 is somewhere in there. And what we do now is we take an average of those two and say that is the third quartile. So it's 24 plus 27, and we divide out and we get it to be 25.8. Sorry, that should be divided by 2 in that formula. In fact, I think I can change it from here. No, I can't. That should be divided by 2. So 24 plus 27 divided by 2, and it's 51, add those two together, divided by 2, because we're taking an average of those two, which gives us 25.5. So that's how we calculate the third quartile, which is fairly straightforward. We also have something called the interquartile range, the IQR, which is the spread of the middle 50% of the data. So the interquartile range is the upper quartile minus the lower quartile. We knock off the top bit and we knock off the bottom bit, and we look at the spread in here. And the reason we do that is because sometimes in data sets we have extreme values, outliers. The extreme values may lie over here somewhere, so just chop them off. They're just unusual pieces of data, and they're not typical of the data set. So just knock them off. So the interquartile range is the upper quartile minus the lower quartile, Q3 minus Q1. The interquartile range is a more useful measure of spread than the range itself, because it describes the middle 50% of the data. And if you knock off the bottom quarter and the top quarter, of course you're left with 50% of the data in the middle, and you look at the spread of that 50%. And that gets rid of the, as I said, the extreme values. If we took the whole range, the range of the data, it would be the maximum minus the minimum. But that would take in the extreme values. So the interquartile range is often used. Just take the middle 50%. In this case here, it means that 50% of the data ranges from 20 to 25.5. And the interquartile range, therefore, is 5.5 when we subtract it. So it's the range of the data here is about 5.5. It's the middle 50%, the range of the middle 50%, which is 5.5. Now, let's look at some notes about this. The quartiles divide the set of measurements into 4 equal parts. And here we've got the full data set, and here we've got the first quartile, which is the first, if you like, 25%, then the next 25%, and so on. First quarter of the data, the second quarter of the data, the third quarter of the data, and the fourth and final quarter of the data. 25% of the measurements are less than the lower quartile. So 25% fall in here. 50% of the measurements are less than the median. So these 50% are less than the median here. 75% of the measurements are less than the upper quartile. So here's the upper quartile, Q3, and 75% are less than that. So 50% of the measurements are between the lower and the upper quartile. This 50% in here are between the lower and upper quartile. This is the interquartile range. The lower quartile, median, and upper quartile are denoted by Q1, Q2, and Q3 respectively. The median is also denoted by M, sometimes in statistics. So this is I think, a rather straightforward little class on the median and quartiles, and that's all really I need to say on this subject. So thank you for watching.